Now, we have a bunch of products that are sitting around here. They're actually much smaller and much more efficient. Could you tell us a little bit about some of those?
The first area for gallium nitride into mass production was in the mobile fast charger market for cell phones and laptops. Initially, with some smaller brands in the aftermarket space, such as Anker, Belkin, and Spigen, and then once the market has gained confidence in this new technology, into the big players. We're now at the stage where 10 out of the 10 top mobile OEMs are using Navitas GaNFast power ICs in mass production. And you can see here some of those names: Dell, Oppo, Xiaomi, Apple, Samsung, Lenovo. So this is a huge advance. This is where we use the speed of GaN to shrink the device for ultimate portability. 3 times faster charging in half the size and weight. Here we're looking at some of the technology inside those devices. On this side, we look at a competing product using GaN, but at a very low frequency. This is around 100 kilohertz. In this version, much thinner, much smaller, this is Navitas GaN running at very high speed. And you can tell a huge difference in thickness and total size because running at high speed. When it comes to device integration, on the left-hand side, we see a competitor approach to do what's called a half bridge. This is using discrete GaN transistors and a lot of shrubbery, which takes board space, extra cost, extra complexity, and is not reliable. You can see if you zoom in, there's a big hole in this device. So that's an unreliable system. Here we see the ultimate in integration. This is Navitas half-bridge GaN power IC. Very simple to use, rated at 2 megahertz and very robust. Using this technology, we can go into high power chargers. This is an example of silicon at 120 watts at low frequency. You can see the amazing reduction in the equivalence using the GaN power ICs, and these are some of our QFN devices which contain the GaN power ICs. This is a 150 watt silicon unit. This is now a 300 watt using GaN power ICs, an amazing reduction using that high speed integrated technology. In the home appliance and industrial space, one of the major applications is to turn motors, to turn the wheels, turn a pump, turn a compressor. In this case, we're looking at a 1 kilowatt silicon-based motor drive, and you can see along the pink edge there are 6 TO220 silicon IGBTs to perform that function. The exact same function is enabled in this unit. This is a 1000 watt motor drive using the GaNFast power ICs with the GaNSense technology of lossless current sensing. An amazing reduction in size and weight and cost. On the left-hand side here, this is an application for something like a vacuum cleaner or a hairdryer. Here we're using 3 of our half-bridge technology devices, again using that current sensing technique to make the smallest motor drive possible. As we move into higher power applications and different areas of the market, this is a look at home appliance. At the back here we see a silicon-based 60 watt power supply for something like a washing machine or a tumble dryer. This is now the small size version using gallium nitride power ICs. You can see that by going to higher switching frequency, greatly reduce the size and cost of this kind of component. In this example, we're looking at the TV space. This is a traditional TV supply using silicon. Due to the inefficiency, we have these big heat sinks. Due to the slow switching speed, we have huge transformers and EMI filters. And the big problem with TVs is the thickness or the height of this entire board. Everyone wants a thin TV, and this thing sticking out the back, not a good idea. This version, this is now a 420 watt 3 output design using the GaN power ICs. We have the main PFC and input filter area here, and then splits into 3 solid state planar transformers for the 3 output voltages. This is less than a quarter of the height of the original design. This gives you a thin TV. Now we move to automotive, the electric vehicle. In an electric vehicle, there's the charging function and also turning the wheels, a traction motor. The charging function, we actually have 3 different applications going on. In a simple case, we simply take AC power and charge, say, a 400 volt battery. And this at the back is an example of a 6,000 watt, 6 kilowatt silicon-based AC to 400 volt charger. The unit at the front really is a next generation technology. This is where we're talking V2X, vehicle to everything. Now in this block, we have 6,000 watts of power conversion from AC to 400 volt DC. But if the power in your house goes out, this will also discharge or go bidirectional and take power from the car, converted back into AC power for your house. This also contains a DC-DC step down because you need to go from 400 volt battery down to 12 volts for your seat motor or your navigation system. So we've crammed 3 functions with a higher efficiency and a lower system cost than the old traditional silicon system. In data center applications, the main drive is on power, largely driven by AI processors. Right now, the NVIDIA Grace Hopper chipset means 1600 watts per motherboard. As a result, the power demand per rack is increasing from 30 up to 100 kilowatts. And to do that, we need to get more power converted to the motherboard. In this case, this is a silicon-based CRPS standard unit. This is a 2000 watt AC to DC unit using silicon. Now we're looking at a much smaller form factor and more than twice the power, so 4 times power density increase with a higher efficiency and a lower system cost using GaN power ICs. Our new GaN safe technology using the toll package is perfect for this. And here you can see one of the daughter cards used within, showing the 8 GaN safe packages in the toll package.